Thanks for watching my video. I wanted to share some upgrades I've done to my DIY hot tub and swim spa. I'm going to talk about the cover that I made and installed, and then I have some notes about the power factor correction for the pump motors and why I bothered with this. Next, I struggled with the bump paint and the pressure treated wood developing stains, so I made a vinyl pool liner. And lastly, affixed to an issue with the boiler, I replumbed the circulation pump heat exchangers and added an overflow reservoir. First, the cover. I made the cover from materials I bought at a home improvement store. Lightweight 1/4-inch plywood, 1x4 pressure-treated pine boards, fiberglass reinforced plastic panels, and extruded polystyrene installation foam boards. I hinged it in the middle so that I had two 4x8 panels that fold over on each other, and then it's hinged again where it meets the hot tub. This allows the cover to remain aligned to the hot tub and is relatively easy to lift. Not so easy for a child though. The math behind this, how this cover works, started with the 3.5 inches of extruded polystyrene foam. It has an R value of about 15, so dividing 1 by 15 gives the U value seen in the table. Multiplying the U value by the area and the difference in temperature gives the amount of heat loss in BTUs per hour. So this example shows the process, but the specific result for this cover is that I lose 9,200 BTUs when it's 100 degrees inside and 0 degrees outside per day. That's about 3 cents of natural gas or 35 cents in electric utility costs if it was heated with electricity. Here's a view of the rope pulley that I used to lift the cover. There's a thin stainless steel hook that fits into the seam between the covers. This shows the covers as open as I can get it without hitting the roof. And then here is how I made the multi-compartment wooden box. I made cuts for the corner supports and cut the foam to fit tightly inside. Lastly, I pre-drilled the XRF sheets and attached them with stainless steel screws to the wooden frame. This project comes after another recent project that I completed, which was converting my home to run on an off-grid solar power system. While this is great for saving money on the power bill, it also has some challenges. One challenge is that the power quality is not as good as the utility can provide, and that anything that can be done to improve the power quality helps more than it costs. So one issue is that the motors with a low power factor cause LED bulbs in my house to have a non-consistent light level, and the pool pump is one that created a noticeable flicker. So I measured the power factor with an inexpensive kilowatt meter, and using an online calculator, I discovered that I needed to install a 10 microfarad power factor correcting capacitor in series with the two electric motors. This PFC capacitor is switched with the motors, so it doesn't do anything when the motors are off, only when they're on. The power factor improved from 0.91, which is not even that bad, to 0.97, which is as close to 1 as it's safe to go. Here we see the capacitor plugged into the switched outlet. The power factor of 0.97 helps with the LED lights. The inverter does not really see any reduction in power draw from the battery. Here we see -7 amps at 48.3 volts, but as best I can tell, inverters like I have, they don't struggle making reactive power, but it does create a little bit of waste heat. So getting that power factor closer to 1 will save, maybe 1 to 2% in efficiency. The next major upgrade I made was the vinyl pool liner. I made this out of sheets of scrim reinforced liner I bought on eBay for $130. I trimmed it to fit the pool with as few seams as possible. So you can think of it as a large U shape with the sides heat welded on. Here's the liner being made into a plus sign shape. The top edges are hemmed over to form a thicker section where it mounts to the side of the pool. This is a view of the hemmed edge. This is a view of what an inside corner will be when it's laid flat. The sides were heat welded on my kitchen peninsula, and so much vinyl can be a real cumbersome challenge to position. This view shows the top edge is lined up at the top corner with 1 inch of overlap. The weights finally get some use. The inside corner was a real challenge. I decided to melt it down with all the folds and then heat weld over it a 5-inch diameter circle of vinyl to double seal it and strengthen the corner. After the liner was installed, while I didn't show it, I used a 1x2 solid PVC trim board to sandwich the liner to the frame of the pool on the top. And I put a stainless steel screw every 4 inches to hold it in tight with countersunk panhead screws. Onto the heat exchanger, I had an issue with air bubbles in the flow lines, so I repositioned the heat exchanger lower, mounted the pump at an angle, and placed an overflow reservoir at the highest point of the coolant loop. This resolved the bubble issue. Thank you for your interest.